All right, well, looks like this is a pretty popular talk. We could wait a few minutes for more people to trickle in, but I think we'll go ahead and get started. Thank you so much, everyone, for coming to my talk. I know there's a lot of really great presentations, especially in this time slot, and I really appreciate you guys taking the time and coming in having this conversation with me. The talk's titled, You Have 2 Seconds to Respond. And I know what you're all thinking, oh, that's that guy that had that absurdly large mask walking around. And now you know why. It's because I'm deathly afraid of my beard catching COVID. If it has to isolate for 2 weeks, it's really going to damage our working relationship. I don't know if any of you got to check out the lightning talks. They were downstairs for a good portion of the day yesterday. There was a fellow towards the beginning that had some really great ideas for sale, like he was selling ideas on how to give your talk and stuff. He had some fun ones like I'm not going to buy. I didn't buy any of them, but he had some fun ones like having some plants in the audience, like yell stuff out during your talk. Okay, I guess I owe that guy $1. If anybody knows who that was, I need to go find him. I guess I owe him something. So I'm speaking on behalf of A2B. It's pronounced A2B, as in we're allowing trucks the ability to go from point A to point B. And A2B, we're building the financial infrastructure for commercial fleets. To get a little more specific, our flagship product is a fuel card for trucking fleets. So that as these trucks are going down the road, if they need to stop and get gas, they swipe our fuel card to purchase their fuel. And there's a few reasons why this is needed in the industry. Legacy fuel cards don't work at most gas stations. You have to go to very specific gas stations. They have very limited tooling. They're kind of unreliable. Most truckers I've spoken to really despise their legacy fuel cards. And so we're kind of reinventing it. And we're reinventing it on the Visa network so that it'll work at any gas station, not just specific gas stations. We also don't charge any fees. And not only do we not charge any fees, we also provide discounts. So they're actually saving more money when they use our card. And we offer a lot more tooling, and we can get a lot more sophisticated about how our customers can use our fuel cards. And they can use it for other expenses such as maintenance, repairs, stuff like that. We've also launched a payroll product. It's a great way for our truckers, who many of which are underbanked. They don't have access. They have small banks in rural areas, or they don't have banks at all. And so our payroll product allows them to get paid directly while they're on the road without having to deal with paper checks that are maybe getting mailed back to their home. So that's a really great product as well. And we're continuously adding more financial products to our portfolio. We've had quite a journey. A2B's only been around for about a year now, and we already have over 25,000 transportation businesses that are using our products. And we've got about 20 to 25% month-over-month growth. We raised a Series A and a Series B, with over $100 million in venture capital raised so far. Also, we're hiring. Just a brief bit about me. I'm Justin Powers. I think depending on where you saw the talk and where it was printed or online, you might have seen 3 different names. I'm Justin Powers. I'm giving the talk today. I've been working remotely in the Southern Sierras for the last decade or so. In fact, I enjoyed it so much, being in this outdoor playground, that I created a co-working space so other people could work where they're playing. So feel free to come join me in Kernville, spend all the time you'd like. Well, let's change gears and talk about the title of the talk. So we called it You Have 2 Seconds to Respond. And what we're referring to when we say that is when the customer is at the gas station, they swipe their card at the fuel pump, Visa gives us 2 seconds to respond with an approval, a denial, and in some cases, how much we approve it for. You imagine if they haven't actually pumped the gas yet, we don't want them to pump an unlimited amount. Depending on how much credit they have available, we can authorize a very specific amount. And this endpoint that Visa hits when they're looking for that approval or denial, is unquestionably the most critical part of our infrastructure. You can imagine that if we don't respond within 2 seconds, what's going to happen? The way we have it set up is it'll automatically approve the transaction. That opens us up to a lot of risk, opens us up to a lot of fraud. So we just can't have that. We can't let these transactions auto-approve. If we make some mistake and we're approving transactions that we shouldn't be approving, then that opens us up to a lot more risk as well, opens us up to fraud. And what's even scarier to me is if we decline transactions that we should be approving, and what that can lead to is a trucker that's stuck on the side of the road without a way to get to the next gas station because they can't get any fuel. So that one in particular is my personal nightmare. I don't want to, when I'm pushing out changes and working on this infrastructure, it keeps me up a little bit, like thinking like, man, what would happen if I mess something up and some poor person's out in the middle of the night at 3 a.m., trying to just get across the country and they can't because our fuel card's not responding. So this endpoint can't be blocked for any reason. And what that means is it creates some very specific constraints around this endpoint in a lot of different ways, not just the time constraint. There's other constraints that we have to be aware of as well. And what this talk is about is how do you build, when you have constraints, how does that change the way that you build and the way that you deliver new functionality? Some of the constraints we have to think about is constraints about the inputs and how they can vary or how they might be highly constrained. About the outputs of whatever functionality you're making. Sometimes you have very specific constraints around that. Sometimes you have time constraints. Oftentimes we're kind of lucky and we have large leeway in that, but in some cases we do have, in this case we have very specific time constraints. And then correctness, which is the one that we usually focus on. What are the consequences if something goes wrong? Is that going to directly impact your business? And how do you build things if that is a very tight, important constraint? So talking about the inputs. For this card swipe that we're talking about, for this event, somebody swipes a card and we get a request from Visa. There's actually two different kinds of inputs that we're concerned about. Visa gives us an input. They say, hey, we have an authorization request. It's coming from a merchant with this name. It might have a merchant category code that tells us what kind of merchant it is. Because as I mentioned before, we can our cards work for fuel stations, for maintenance, repairs, but like you can't go and buy something off Amazon with the cards. They're highly restricted based on the merchant category. Sometimes it comes with a dollar amount. Sometimes it doesn't. Sometimes it comes with a dollar amount, but Visa wants us to actually give them a proper dollar amount for how much we would authorize. But then other sources of inputs are the actual state of the customer and their account. So do they have certain merchant categories that we've enabled for them? Do they have, how much available credit do they have? And that part's a bit more complicated than you might expect. You might think it's a very simple calculation to just look at how much they've spent this month and how much they have left, but our payment terms were on what's called a net 7. So at the end of the week, we look at what your balance was, how much you spent during the week, and you make a payment. You have a week to make a payment on that, which changes how much credit you have for the next week. And so it's a little bit complicated, and it's not super straightforward, and there's a lot of edge cases in there that really change what your available credit might be. When we're talking about outputs, in our situation, there's not as much of a consideration. Outputs aren't quite as constrained. We do want to pass back some metadata to Visa when we're approving these transactions. And if we push incorrect metadata or if it's formatted incorrectly, it'll raise an error in that and the transaction gets declined. So we have to be very, very careful about any change we're making. Making sure that we're not changing something accidentally that's going to cause those transactions to get declined. But also, of course, with the outputs, you have to worry about if they're correct. We've got a large variability in inputs. We've got a large variability in all the different edge cases and in our customers' accounts and how much they paid and when they paid and extra payments they've made to try to raise their credit limit. So there's kind of a lot more than kind of your typical test cases can easily cover. There's a lot of edge cases that we're not aware of until we actually see them in production. And as I alluded to, we have a hard constraint of 2 seconds. First, I want to address the elephant in the room. In the world of web APIs, 2 seconds is like forever, right? Especially if you go to any other conference other than RailsConf, if you tell them that we're talking about how to keep an API endpoint under 2 seconds, they'd probably laugh you off the stage. I'm not saying that we're doing anything innovative by consistently being under 2 seconds, but what I do want to talk about is how those constraints actually change how you design your system and how you deliver that functionality. So I mentioned this is the most critical part of our infrastructure, but it's also the part of our infrastructure that we want to invest the most time in, we want to make the most changes in, we want to really innovate in the way that we approve or deny these transactions. For example, we want to add a feature, and we have added a feature where if your truck's in California, but the card is swiped in Tennessee, we can say, oh, well, that wasn't your, that wasn't you. It must have been like filling up your personal vehicle or something like that. And we can do that because every truck, by law in the United States, has to have a tracking device in it. And we can integrate with those tracking devices. And so we can actually get down to the level of making sure that the truck is within 2 miles of the gas station where the card was swiped. But there's a lot of complexity. There's a lot of edge cases. There's a lot of situations where maybe the location of the merchant is like miscoded from Visa, and they're actually somewhere else across the country. There's a lot of weird situations there. We have a feature where companies that want a little more security, they can send an SMS to A to B to unlock the card for the next 30 minutes. That's a great protection against fraud. We have other features like allowing each driver to have an individual PIN that's specific to the card. And we're integrating things like machine learning and automated fraud detection into our authorization into this endpoint. So as we're adding all these features, if we are terrified to make changes because it might leave a driver stranded on the side of the road, how do we change the way that we build things so that we're a lot more confident in that? So there's a number of things that we can do to address being able to be able to make changes safely and with a lot of confidence. Some things that you want to kind of look out for when you're building, and some things that we've been looking at is isolation. So we don't want to allow a failure in one part of our system to take out the rest of the system. If we have one part of our system that is being really hard on the database or is has a memory leak or something like that, you don't want it to impact the part of your system that's the most critical. There's a lot of strategies for this. There's entire talks about this. You can do things like adding redundancy, adding caching. You can split up your application to have your most critical components run on separate hardware. You can do all these things regardless of whether you're working in a monolith or working in microservices. There's a lot of strategies for that. We're not really going to get into them in this talk, though. Something else that just makes it really easy to be very confident in the changes you make is be very, very devoted to the single responsibility principle. Build your classes, build your code in such a way that your code's only doing one thing. One piece of advice I would definitely give, try not to mix your business logic with your models or your database layer. If you want to be able to have specific inputs and specific outputs that you can test without having to worry what the state of the database is in the middle there. It makes a lot of things a lot easier, including some of the strategies that we're going to be getting at towards the end of the talk. I could spend a whole talk on just designing your classes to make them easy to test, but I think there's been some other talks this week that have covered that pretty well. And if you do this, it makes testing things in isolation a lot easier, makes a lot of the things we're going to be talking about later a lot easier. And there's actually another talk going on at the same time that I believe probably addresses this pretty well about kind of a functional programming style that would make this a little bit easier as well. Another thing that you can think about is making sure that for those business critical portions, only do the work that you absolutely have to do right at that time. If there's anything that can be done later, use some sort of async process. There's a lot of tools out there for this. I'm personally like to fawn over Sidekick. Mike Burham's here. He's been a great part of our community, a great part of RailsConf. And it's a really great library to make sure that, like for example, in our system, when you swipe your card, I mentioned you get discounts. There's a little bit of calculation that happens there. We're reaching out to some third-party vendors. We don't want to block that 2-second transaction. So we do that later. We kick off a sidekick job and just say we'll deal with that later. And concurrency, and this is where it's going to get perhaps slightly controversial. One of our primary constraints is time, but there's, as I mentioned, a lot of different things that we're doing at the same time to make sure that this transaction is valid. As I mentioned, at the same time we need to calculate their running balance, calculate how much they have available this week. But we're also checking the location of the truck. We're checking the location of the vendor. We're checking to see if they've unlocked the card using SMS. And so we need a mechanism that as we're adding more checks, it doesn't increase the amount of time it takes to respond to Visa. And so in our case, we decided the best way to do these would be to run these checks in parallel. Word of warning, concurrency makes things complicated. To quote the great philosopher Aaron Patterson, just because you can doesn't mean that you should. So I believe we should all strive to keep our systems very simple, very easy to understand, very easy to maintain and improve. Multi-threading is fantastic for frameworks. If you add it to your application code, you're adding complexity that's going to be difficult to mitigate and to work around. And it adds risks. Clara, and I'm going to mispronounce her name, I believe is Morganier, on Tuesday did a great talk about using concurrency in Ruby, a lot of the different strategies for it. If you get the chance to watch it, go back and watch it on YouTube, it was a very good talk. She mentioned some of the different strategies you can use for concurrency and some of the typical bugs you might run into and some of the risks. There's using thread.new, which has been around a long time. There's newer features in Ruby like fibers and R-actors. We're using thread.new, but we are actively looking to see if one of these other solutions might be a good fit for the job. Some of the other things you need to be aware of if you're looking at doing spawning threads in the middle of your application code, paying attention to the connection pools you have. If you've made a calculation about how many database connections you need for the number of, say, Puma workers you have, then you start spawning extra threads and they start connecting to the database, those are going to get out of control, so you need to be aware of that. Be aware about shared context, shared state between those threads. And you have to be a lot more purposeful about observability. For example, if you're, we need to know now that we're doing things in separate threads, we need to know not just how long it takes for this endpoint to return, we also want to know how long each of these threads is taking so that we can be proactive about dealing with issues. And also testing this kind of functionality is a little bit difficult, especially if you don't want to rely on sleeps to test things like timeouts. Here's an XKCD about regexes, but I think the same thing probably applies to threads. I've got 99 problems, so I use threads, and now I have 100 problems. So just word of warning, just be careful about that. So here's kind of a quick sketch of what that endpoint is doing in our situation. So we've got this authorizer runner that gets the request. We spawn thread.new for each different kind of sub-authorizer that we have. So we've got, in this example, a credit authorizer, one that's looking at the location of the truck, one that's checking the SMS unlock. Anybody that's worked with threads, you've seen thread.join, where you wait for the thread to finish and you get the results of the thread. What I didn't realize until very recently is you can actually pass a timeout to that method, which is a number of seconds. So in this case, at the bottom here, you can see, and I don't think I have a mouse here. Oh yeah, here you can see we're passing 1.5. So we're saying, okay, all of you threads have 1.5 seconds to finish. If you haven't finished, then you're going to give me the result anyways, and you're going to keep going. It does not kill the thread, and that's important because timeouts can do really dangerous things. Don't ever use Ruby timeout if you can help it. So you can see in this example, let's say the credit authorizer took about a second. It said, yes, we want to, based on their available credit, we want to approve it. We want to approve them for $500 worth of fuel. But the location authorizer looked and it said, hey, this truck is nowhere near the gas station. It says to deny it. And something happened with the SMS unlock. It took too long. It took over a second and a half. We don't get that result. We don't care about that result. We use what we've gotten to make the best decision we can. So we're going to deny it based on the fact that the truck wasn't in the appropriate location. The code that does all this is a little bit arcane and a little bit difficult to do in a short talk like this. So we're going to skip it, but we're going to have some code at the end for one of the other features that we've been working on. So in talking about working with constraints, how do you have the observability to know, if that business critical part of your system, how well is it working? The biggest thing is going to be observability. You have to be absolutely certain that this critical part of your functionality is working. You need to know how it's performing. And for that, monitoring is key. We use a tool that's not sponsoring this conference, so I'm only going to mention the sponsors of the conference. We've got some great monitoring solutions. New Relic, I know, is in the room. They're a great solution for monitoring. Scout is also sponsoring the conference here, and Honey Badger. And you can use all of these to get a lot better insight of those critical portions of your application. And there's going to be some great talks on exactly how to do that. But just keep in mind that that's going to be absolutely key. That you need to know not just how long something's taken, but some of the other things that we're looking at is what's the ratio of, for example, denials to approvals. If we all of a sudden start approving 100% of our transactions, something's probably wrong there. We should probably page the on-call and roll back whatever code was just released. If it's the other way around, if we're suddenly denying a large portion, we need to page somebody and roll it back. Even like watching the approval amounts and having some anomaly detection. As you start getting into these higher end tools like New Relic, you get things like anomaly detection that can kind of keep an eye on that and see if they start to see anything weird. And you can instrument very specific parts of your code to see how long they're taking to respond. Absolutely create some easy to use, easy to understand dashboards that whoever is going to be supporting your code, especially any on-call, they need to be able to look at that within a few seconds, know if something is wrong and where that's happening. They need to be able to dive into that pretty quick. And so designing dashboards is not something that as developers we tend to spend a lot of time on, but I highly encourage you to spend a lot of time, invest time in building very easy, very actionable dashboards. And if something goes wrong, you should have proactive alerts. You should be paging somebody to say, hey, this critical part of our business is not working right now. We need to get this under control. And another strategy that we're using, and this one's kind of fun, and we're going to spend the rest of our time on it, is shadow mode. So for us, just monitoring isn't enough. I don't want to push code and then find out that it wasn't working. And the result of that is that maybe some drivers are stranded on the side of the road. That's not acceptable to me, and it's not acceptable to the company. But we want to be continuously pushing new functionality, so how can we do that? One common strategy is called shadow mode. There's a few different ways of doing this. The way we've chosen to implement this is every time we get a request in production, we handle it using the existing code, and we push it back up. We push the result back to Visa, and then what we do is we kick off a Sidekick job. I'm going to keep mentioning Sidekick, and we will run with the same inputs. We'll run it against the existing code and the new code that we want to roll out, and then we can compare the outputs and see if we're making like refactoring changes, they should be identical. They should never change, and we want to see what the difference is if they do change. If we're changing our logic for when we approve somebody, we need to know exactly when it's changed and why it's changed, and be able to have some observability around that. And I mentioned before, like single responsibility principle. We're not perfect at it. We're still improving and refactoring things to get our things nice and tight. While we're working on that, it's kind of helpful to know what's going on inside of those code. And so we've actually added a little bit of tracing functionality where you can actually see what the state is of your logic as you're stepping through the code, and some of the data and variables that's inside of your code. And yes, I contradicted what I said earlier, but you know, we're all human, and life is rough. There's other strategies for doing this. Another popular strategy is to record all of your API traffic and then replay it against a non-production environment and compare the results, make sure that's working fine. There's some other strategies we're not going to get into, but this one seemed to work best for us. So before I get into kind of stepping through the code that we've written, I just want to call out these are two tools that we absolutely would not be able to do this without. Sidekick, I believe, who here is using Sidekick? Okay, so needs no introduction. If you're not using the enterprise version, I would encourage you to talk to your employers and have them pay for it and support that open source project. Flipper is a feature flag framework that also has an enterprise version that's worth paying for and is just a great piece of software that we're using. If any of the maintainers of any of those projects are here, I would like to buy them the beverage of their choice because they've saved me so much. So I've only got a few minutes. I'm going to run through this really quick, and then I want to look at the code. That real-time authorizer, when the request comes in, it'll kick off a Sidekick job. And in that Sidekick job, as I mentioned, we're going to run the same exact code that we ran before, but this time we're going to instrument it. We're going to add some tracing around. We're going to record the outputs. We're also going to do some tracing and capture some values within the code. And there's kind of a cool tool for using that we're going to talk about. And for each of these, we're just saving a record to database using Active Record. It's a shadow snapshot here. We're capturing the inputs, the outputs, those variables that we've captured, whether it's the control. So if we have the feature flag off, we're calling it control. If the feature flag is on, we name that variant, which feature is it that we're trying to roll out. And then for any of those variants, we're capturing a diff of the outputs so that we can compare them later. And here's how we built it. This is very simplified code. It's missing a lot. I just want to kind of give you a gist of how we built it. If it's something that there's a lot of interest in, maybe we'll think of coming up with a way of open sourcing it. But the first thing we do is we define this this list of hashes that represent our interests. So what this is saying is, as I'm stepping through the code, when I get to the credit calculator, there's a variable called pending amount. I really want to know what that was at that point in time that we were stepping through, that we were running that logic for both the control and the variant, see if that changed. Same thing in some fictional transaction service. If there's a transaction count, if there's amount due, those are variables that we're going to keep an eye out for. And we pass those to this class called Shadow Tracer. And all this is running inside that Sidekick worker. And I'll get into what that Shadow Tracer looks like in a minute. And then in that same Sidekick worker, we run the same block of code twice, once with the feature flag flipped on, once with it flipped off. And this code's a little bit, there's a little bit going on here. That tracer that we created earlier, we told it what we're interested in. It has a method called capture, and we pass it a block. And inside that block is where we actually run the code that we're interested in. In this case, we're just running this credit authorizer. We're telling it whether the feature's enabled or not, and we're passing it the request that we got from Visa. And then based on that output, we have this method that does a little bit of cleanup and then just saves that information to Active Record. So we're saving whether it was a variant or not, what the inputs were, what the outputs were, and what those captures were, and it'll take care of calculating the diff, and that's something that we're not really going to go over. But that Shadow Tracer, here's a little bit of code that was extracted from that class. We're using this tool called TracePoint. Has anybody here had to use TracePoint? It's a pretty cool bit of functionality. It's built into Ruby, and you can subscribe to events that are happening as your Ruby code is being executed. So in this case, this line trace, what I'm doing is I'm saying I want to in any code that runs while this line tracer is enabled, if there's an event called line or return, which means we've started executing code on a new line or the method has returned, I want to run the code inside the block. So every single line that's run, we're going to run this, this code that's inside this block. This is why we're not running this in concurrently when the transaction is running and we're responding to Visa, because we could do something really easily and just screw up our performance. But we're running this only in a Sidekick worker where performance doesn't matter. And then you don't really have to get too deep into how this is working, but essentially what we're doing is we're looking to see, okay, for each line that we're running, are we in that class that we cared about? If we are, let's look at all of the local variables that are available to us right at that point in time. If any of them match those things that we're interested in, I want to stash it away so I can look at them later and see what they look like. And all the capture method is doing is it's enabling that trace point, and then at the end it's disabling it. And I realized I must have deleted some memoization there, because that's going to work a little bit differently than you would expect. And that's kind of one of the tools that we've used so we can push out changes and have 100% certainty that it's working exactly the way we expected. Got a shameless plug. I'm out of time, but we are hiring. Come see us down in the Expo Center. We're hiring for a lot of different roles. If any of you are here at this conference, you are our target audience. We are the folks that we want to hire, so come talk to us. And I'm out of time. I can't take questions up here, but I will be available down here at the side if anybody has any questions. And if they're this types of questions, that's totally fine. Thanks, everybody.